All right, we're talking about linear inequalities in two variables. Thank you. And we need to make sure that we're understanding what we're looking for here. But every lesson in this chapter up to this point, so all the way to 6-11, has been dealing with linear equations. And now today we're dealing with inequalities. Does anyone remember what an inequality was? What's an inequality? Yeah, well, how do you say them? You could say one is greater than, one is less than, but then there are three others.
Not equal to.
Not equal to is another one. Greater than equal to, less than equal to. Okay, so you got the 5 that you have up here. We're not going to deal with the not equal to, but we're dealing with these 4 right here. These 4 inequalities, and then you're like, what are you talking about here? We'll get to that in just a bit. Okay. So these inequalities have not one variable like we did months ago, but they have 2 variables. And you're like, how does that work? I need to do a recap of the one variable. So do you guys remember you got x, for example, is like less than or equal to 3? Do you guys remember you'd have to graph that on a number line? And who remembers how to graph that on a number line? Here's my number line. Yes, sir?
3.
And then I wanted you to go 1 above and below.
Do a circle in the middle.
What kind of circle?
Close.
Okay, closed circle. Why is it closed? Because it has the equal to symbol. And then what would I do after that? Line going to the left. Why is it to the left?
3 is bigger.
Yes. And x, whatever x is smaller than 3. Okay, this same understanding applies to linear inequalities with 2 variables. It's the same idea. You have either a solid or solid or open circle, line going one way or the other. It just depends on what the inequality is. So we're going to apply that to these kind of problems. So the first problem I want you guys to write down, y is greater than, let's change that up just a little bit. Y is greater than x plus 1. X plus 1. So that's our inequality. Okay, what form does it look very close to? Do you guys remember our 3 forms? It looks really close to slope-intercept form, but why does it look a little different than slope-intercept form? There's one real difference. Yeah, it doesn't have an equal sign, but this can be considered slope-intercept form. Y equals mx plus b. And that's nice because that's going to help us on our solution. Okay, great. Do you know how many answers there are to this problem? It's not one answer. It's not 2 answers. It's an infinite number of answers. And I need you to give me all of them, just like I made you give me all of them here on this number line. So if I told you on this number line, give me all of them, you could have done 3, 2.9999991, 2.9999992. We can list them all out. Or we can give a little graphic, and then you showed it all to me. I get it's all these numbers, including 3. Okay, so what I want to do here is I just want you guys to imagine that this was in slope-intercept form with an equal sign. So I'd write y equals x plus 1. Y equals x plus 1. So imagine that. I gave the last class graph paper. I don't think I needed to give graph paper. I think you guys could do it without it. So I'm going to see how this goes with your class. I think you guys can handle it. But these graphs don't have to be perfect, but they do have to be neat. So I'm not looking for perfection, but neatness. You're like, oh no, graphing? Yes, graphing. Okay, how many of you could graph this on a coordinate plane? Can you guys graph this? Okay, if you can, go ahead and get started. And you only need to go like a 4x4, or sorry, 3x3. It doesn't have to be big. Just graph this line right here, y equals x plus 1. That's the first thing I want you to get. So I got a 3x3x3 graph. And who can tell me where I need to start here for this graph? If it's in slope-intercept form, I can start where? Eva, do you know where I start?
Well, I know that n is
M is
Or 1.
1. It's in front of x. And then what's the y-intercept? 1. So that's why I start right here on the y-intercept. Oh, positive 1 right here. Sorry. Positive 1 right there. And then what's my slope, Josiah? 1. Is that positive or negative? It's positive. So where do I go? Up 1, over 1. Up 1, over 1. Get a couple more dots. Up 1, over 1. Up 1, over 1. But what if I wanted to go the opposite way? Sam, what do I do if I want to go the opposite way? Okay, and to keep it with slope, you go down 1 over to the left. Yep, down 1 over to the left. Okay, and then go ahead and connect those. And you get your line there. That is y equals x plus 1. That's the graph right there. How many of you could do that on your own? You just need a little reminder? Some of you are still doing it. Okay, good. Most of you could do it. All right, but that's not what they gave me, is it? They did not give me this equal sign. They gave me an inequality greater than x plus 1. So, I don't know what that means. But greater than, what do you think of when you think of the word greater than? You think something that is bigger, which is usually which direction? Up, above. And so I want you to look at the line again, and I want you guys to do this little exercise with me. So here's the line, right? Here's the line. Can you guys point to me what part of this, or what part is above this line? So where's above this line? Just point. Just point, yeah, just use your finger and point. So you should be pointing this way, right? Like this way. Okay, it's this region right here. What's below it? This side, right? You guys good on that? Okay. What's above this line? What's above this line? So I'll kind of show it to you guys. It's still this side. It's this stuff right here is above the line. What's below it then? It's all of this right here, okay? What's above this line? Yay, okay. Most of you are not confused. Below the line. Okay, now I'm going to give you the toughest one. What's above the line? Wait, the line goes up. It's a lot. It's actually this side right here. Above the line is over here. Because if it's up here, well, that's still with the line. Above the line is everything to the right of that line. You're like, wait, how does that work? Let's say this line was at x equals, let's say 2. What's next to 2? 3, 4, 5. Aren't all those numbers bigger than 2? And what about all the numbers to the left? They're smaller than that. So less than, greater than. And you won't get too many of those, so don't feel too bad about that one. All right. So what is above this line? What's above the line? Yeah, good. I want you to shade it. Shade that part that's above the line. And it doesn't have to be perfect, but you do have to show me that it's that region. You don't have to fill in every blank. Although, technically, that shading represents all the numbers that are part of the solution. So, how many points, does anyone know how many points are on a coordinate plane? How many points can I put on a coordinate plane? Anyone? Infinite. How many points can I put in this shaded region? Infinite. How many can I put how many points can I put in the unshaded region? Infinite. Okay, so this is what happened. When you draw this line right here, you just split infinity in half. Half of the answers, or half of the points, are going to be a part of the solution, and half of the points are not going to be part of the solution. And you're like, wait, what are you talking about? Can anyone give me a point? Can anyone name a point that's in the shaded region? And guys, it includes everything. We just don't have to keep drawing it out there. What's a point out here in the shaded region? Philip?
Negative 10, 20.
Okay, negative 10, 20. So somewhere out there? Okay, I'm going to put that negative 10, 20, right? Do you guys agree that that's one solution, or that's in the shaded region? Okay, I'm not sure about that, but look at my inequality. Is 20 greater than negative 10 plus 1? Yes, it is. This is a part of the solution. Can someone give me something a little bit closer to home here? Andrew? Negative 3, 1. This one right here, I'll label it negative 3, 1. Is that a part of the solution? Okay, is 1 greater than -2? Is that true?
Yeah.
Yeah, that's a solution right there. Can anyone give me a point that's not a part of the solution? That's close to home. Don't go too far.
4, -7.
Okay, 4, -7, so somewhere down here. Do you guys agree that's not shaded? That's not a part of the solution? So 4, -7. Okay, is -7 greater than 5? No, that's why I didn't shade that region. In fact, how many points did we say are part of the solution? Infinite, and we just described it by shading it. But some of you should have a question about something that I haven't heard yet. Anything? Any question yet? Got all the answers here and none of the answers here. Yes, sir?
What if it's greater to and equal to?
Okay, what do you mean by that?
Like, for the side.
Yes. Okay. Yeah, you know what? We haven't talked about the points on the line. Do you guys know that there's an infinite number of points on the line? What's this point right here, just for 0, 1? It's 0, 1, right? That little point on there. Is that a part of the solution? Is that a part of the solution? All right, let's check. I don't know. Is 1 greater than 1? Is 1 greater than 1? The answer to that question is no. That's not a solution. In fact, you know how many points on the line are part of the solution? None of them. So this is what I need. I hope you're using pencil, mainly because it's math. I want you to erase that line if you can. And instead of a solid line, I want you to draw, what's up there on my board? A dotted or dashed line. We're going to call that a dashed line. Your book's going to call it that. That's telling me that these points on the dashed line do not fit the inequality. They're not a part of the solution. Like, that can't be. You can't do that. Okay, do you guys remember this? Once you get that drawn out. If you had a pen or some marker, another way to change it would be if you had that solid line. Some people do this, like you had a solid line, and then just draw tick marks next to it or dash lines next to it so you can correct that. But anyway, we've done that already. When you have an equal to sign, what do you do with the circle? You close it or you shade it in. What happens when you don't have a circle, when you don't have an equal sign? What happens to the circle? It's not shaded in, it's open. Do you guys remember that? This is open, this is closed. That's what we're doing. It's the same process. Closed, open. And I'll give you some pointers on that. Okay, let's do another one here. Go ahead and write this inequality down. It's an inequality, not an equation, because it doesn't have an equal sign. Do you guys remember me asking many times, how do you know it's an equation? And what was the answer I was looking for? It has an equal sign. So Hudson, is that an equation? Why not? It doesn't have, it has like a partial equal sign, but it's not an equal sign itself. Okay, good. What form do you think I want to get this inequality in? Slope-intercept. So someone walk me through slope-intercept form for this one. Yes, ma'am? Subtract 4x from both sides. Sorry.
Is greater than or equal to -4x plus 6.
Good. You'd get that on your first step. Good. You subtract 4x from both sides. You get -2y is greater than or equal to -4 plus 6. But do I want what -2y is greater than or equal to? No, I want what y is greater than or equal to. Anna Grace, what's my last step here? What do you think? I want to get y by itself.
Divide everything by 2.
Say that -2. Everything gets divided by -2. So I get y. Wait. What happens when I multiply or divide both sides by a negative? Yeah, that's months ago, and some of you remember you flip the direction of that inequality. It becomes less than. Do you remember that? How many of you remember that after this reminder? You're like, oh yeah, I forgot. Okay. What's -4x divided by -2? +2x. 6 divided by -2, -3. So y is less than or equal to 2x minus 3. How many of you can graph that? Good, graph it. Make it as neat as you can. Doesn't have to be perfect, but try to graph that line. Before you graph it, I have a question for Jack. Is this a solid or dashed line?
Dashed.
Dashed. How do you know?
Or no, it's solid.
How do you know?
It's, less than or equal to.
Good. It has less than or equal to, and you're like, wait, how do you remember that? If I just put these up there. If they have one of these signs, it's solid. If it has one of these signs, it's dashed. So that's one way to remember it. Do you remember what an equal sign does to my inequality? It makes it a closed inequality, an open inequality. So it's the same thing here. So you should have a solid line. I'll just go by fives. 1, 2, 3. Okay. Matthew, where do I start my graph?
Down 3.
Down 3 because the y-intercept is -3. So that's my y-intercept right here. That's where I started. And then, Brad, where do I go from there? Up 2 over 1. 1, 2 over 1. 1, 2 over 1. 2 over 1. Okay, what line do I get here, Darius?
Positive.
Okay, it's a positive line. Good. And then is it dashed or solid?
Solid.
Okay, solid line. So I'm going to connect them with the solid one. Maybe. No one saw that. Okay. Do I shade above or below the line? Good question here. What do you think, Josiah? Below. Why? Last time we did above. It says less than. So you're like, wait, how does that work? Less than means below the line. Greater than means above the line. And what's less than this line? Everything to the, do you guys know, switch direction? To the right. Okay, it's everything here. So shade that in. All that's, and it goes on infinitely, but once you show me that, I get it. Oh, it's that region to the right. Okay. Someone give me an ordered pair that should work according to my according to my graphic. This has to work. I know Andrew has one. Hudson?
Positive 3, negative 1.
So 1, 2, 3, negative 1. So do you guys agree that positive 3, negative 1 should work? Do you guys agree with that? It should. Okay, but does it work? What's 4 times 3? 12. What's negative 2 times negative 1? Positive 2. Is 14 greater than or equal to 6? That checks. That checked. Give me a number, or I should say a point, an ordered pair that does not work according to my graph. Brad. See here, negative 1, 1. So this one should not work. Negative 1, 1. Yep, according to my graph, doesn't work. What's 4 times negative 1? Negative 4. What's negative 2 times 1? Negative 2. Is negative 6 greater than or equal to 6? No. That's why it's not shaded. Do you guys see how I can check these answers? Not very hard. You just put any point in there, plug it back in. But, Alex, give me a point on the line. Give me 1 point on the line.
Positive 3, positive 1.
1, 2, 3.
Actually, no, positive 2, positive 1.
I think positive 2, positive 1. I think that's on the line. Let's check it out. 2, 1. Okay. What's 4 times 2? 8. What's negative 2 times 1? Negative 2 is 6 greater than or equal to 6?
Yes.
Yep, that's why any point on the line would work because I have that little equal to sign. Do you guys see how that works with the equal to and the not equal to? Boom, got it. How many of you are getting better at graphing? How many of you are perfect at graphing? I'm not raising my hand. I mess up, man. I was working with somebody, and I didn't look at the sign right, and so I was like, oh yeah, go up 1 over 6, and then I look back. it's go down 1 over 6. Is that a difference? Yeah. One goes like this, one goes like that. That's a big difference. So be careful with your signs. How many answers did you show me on this graph, by the way? Infinite. Did you have to write them all out for me? No. Oh. I had, it was a 6th grader when we were looking at this stuff. I'm like, if you can write out all the answers to this, you know, I'll give you no homework. And he just started doing it. He was listing out numbers. I'm like, please don't do that anymore. You're not going to get it. At the end of the class, he had a paper full of numbers, and I said, okay, good. Just do an infinite number of these. You got it. Is he ever going to get it? No, and I felt bad because I kept telling him, don't do it, and he kept doing it. Okay, I want you to do this problem, graph it. Please don't be that kid. Just draw the graph, and you'll give me all of them without having to list them all, because you can't list them all. What's my first step in this inequality? I want to get it in. Yes, so you solve for y. Just solve for y. Have you been doing this for a while?
Yep.
Yes, you're getting practice. That's the whole point. Pun intended. Okay, anyway. What do I get on this one? Let's go. Henry, can you help me out? I'm stuck. I don't even know I don't know how to start.
You subtract 2x.
2x from both sides. What am I left with here? Jackson, do you know what I get from this step?
Y is greater than or equal to negative x plus.
So just when I subtracted 2x from both sides, what did I get? I'm left with
You get 2y is greater than or equal to negative 2x.
okay, and it's 2y is less than or equal to negative 2x plus 10. Good. Sam, what do I do here?
You divide everything by 2.
Everything gets divided by 2. Oh, I divided both sides by 2, so what do I do with that inequality? Keep it, because what do you have to divide by to make it switch? A negative. So if it wasn't a negative, you just keep it the same. All right, so I get negative x plus 5. Or negative 1x plus 5. All right, graph that. 5 by 5 is fine. Okay, Sophie, where do I start this graph?
You go up 5.
1, 2, 3, 4, 5. Okay, Hagen, where do I go from there?
You go down 1 and to the right.
Okay, what's the slope? So down 1 over 1 to the right. Why not to the left? I'm still seeing some people like, which way do you know it has to go? Because we go sometimes down 1 to the right, sometimes down 1 to the left. Which one is it?
It's the like opposite of whatever that is.
Yeah, if you think that way, maybe
I
that
wanted to go like a negative one.
that's what it is. Don't I want it to be a negative line? So which way is it going to have to go from left to right? Down. So I have to make it go there because it is a negative correlation, which is that's a long time ago. Make sure. Okay, what kind of line is it though? Solid or dashed?
Solid.
Why is it solid? I'm looking for it because it has an equal to sign. So yeah, it could be less than or equal to or greater than or equal to. All right. And what's less than that line? Anything below it, which is what? Hannah Grace, anything below it, which would be what?
Everything to the left.
To the left. So you shaded this region in here. But if you shade a region and you're like, I'm not really sure if that was above or below the line. Do you guys remember when I gave you the vertical line? Remember how I told you what's greater than this line? anything to the right. What's less than the line? Anything to the left. But you're doing your homework, and if you had one of those, you're like, did he say left or right? Okay, you don't know. How do I check it? Just pick a point. Pick a point right here. All right, does that work? Yes or no? If it does, great. If it doesn't, oh, I must have shaded the wrong place. Give me a point and pick an easy point. Anyone know an easy point here to check? 1, 1. All right, 1, 1 should work. What's 1 times 2? 1 times 2? What's 2 plus 2? 4 is less than or equal to 10? Yes, so that checked. So you know that that part of the graph works, and you can check when that doesn't work. Would anything on the line work?
Yes.
In fact, not would something work on the line. Everything on the line works. Every single point on the line works. Okay, here are the types of problems you're going to get. This is on page 179. Huh. I don't think this is the one I wanted, but anyway. Here's one type of problem you're going to get, and I don't think it's 179. I'm not sure where this is coming from, actually.
Yeah.
Oh, it is. Okay. But this is not the problem I wanted to give you first. So let me give you another one. We'll come back to this one. I don't know if I erased it or something. Okay, look at number 1 is the one I wanted. And somebody read those instructions for number 1. Determine whether. Okay, determine whether or not P is a solution of the linear inequality. So give me y is less than or equal to 3x plus 10. 3x plus 10. And what do you think P stands for? The point. And then they give you the point, which is 0, 4. So they give you 0, 4. Okay, they don't want you to graph it. They just want you to tell me, is that point a part of the shaded region or not? And you're like, how are you supposed to know that? How are you supposed to know that?
So if 0 is x.
Oh. So what are you doing when you replace a number? You're substituting. So you got 4 is less than or equal to, what's 3 times 0? 0 plus 10. Is 4 less than or equal to 10? Yes. So is that point a part of my solution? You write yes. It is a part. That's all you had to show. Let's do one thing. Does it work? Does it fit in? Good. If it doesn't, no. The answer is no. Do it for number 2. Do it for number 2, please. You don't have to write it in slope-intercept form if you're just trying to check to see if the point works or not. Just fill in the blanks, which we call substitution. Okay, on number 2, does the point -4, 0 work? Yes or no? No. What did you guys get on the two sides of the inequality? What is greater than or equal to what, or less than or equal to? What did you get? -4, greater than, -1. Is that true? No. So you put a no. That's the answer to number 2. That's one type of problem you're going to get. The second type we're going to get, oh, that's hard to happen. Let's look at number 5. Number 5, they give us 3x plus y is greater than -1. And let me make sure that is number 5. Yes. Okay, what do they tell me to do in this problem? Because I don't want to do extra, right? Unless you want. I really don't. It says, write the equation of the boundary line in slope-intercept form. Describe each line as dashed or solid. So do they want me to graph it? No. You just have to write it in first slope-intercept form. So go ahead and do that. Get in slope-intercept form. Okay, you should have gotten in that form, and that's part of your answer. That is one part of your answer. And then it asks you, is it a solid or dashed line? Which one is it?
Dash.
Dashed line, and how do you know that? no equal to sign. So it's you put dashed, and that's your answer. That's the second type of problem. Okay? The third type of problem, what do you think they want you to do on those? Just graph them. There aren't many, but you do have to do some. Go ahead and do 14. That's the one we skipped over. Oh, not yet. Okay, so that one is the y is greater than or equal to 2 plus x. Y is greater than or equal to 2 plus x. Is it in slope-intercept form?
No.
I thought y is by itself. But is it in the format? No, what do you have to do then? Yeah, y is greater than or equal to x plus 2. All right, I need 20 of you to get this one right. And if you get it right, we move on to the last screen. If not, I have an extra screen waiting for you. So 20 of you need to get this graph right. So you got to give me a shaded region. I want something shaded in. And if you want to make sure, you can check it by putting an ordered pair from your solution if it works. Okay, finish up the graph, please. Make sure there's a shaded region. And this is how I check your graph. Part 1, checking the graph. Does 0, 0 work on your graph? Say yes or no. Just put it off to the side, yes or no. I'm not giving you which one it should be, but... Okay. It should be a it should be a solid line, and it's going upward. It starts on positive 2, and it goes up 1 over 1, up 1 over 1. And did 0, 0 work? Oh, it didn't work. Bummer. Okay, how many of you got that line, or at least those parts? Raise your hand. 15.
How many of those have you done?
15, right?
20. 15 got it right, yep.
Raise your hand.
Let me say this. For those 8 who did not get it right, tell me what you did wrong and how to fix it. Okay, yes, sir?
So what I did was, when switching the x and the 2, I put x as negative x.
Gotcha. And you know what? That came up in the other class, so I misread. Should this be negative? And why would it not be negative? And thank you for admitting that. Yeah, good. My goodness. All right, you gave the answer already. But if you were subtracting x from both sides, you could have done that. Good. One more. Somebody tell me what you did wrong, how to fix it. 8. I have 7 volunteers. Starting with... Anybody? Sorry, I don't see a hand. I'll wait. That's, I would not, when I was your age, I wouldn't have done that. I would have sat there and said, nope, not me. I got it wrong. But it's okay. I'm just waiting for one more. You're allowed to speak. Nope. Come on, guys. It's okay. Listen, I want you to know this, that Mr. A, in front of you and in front of the world, Swivel has made mistakes, and it's okay. I have less of an excuse to make a mistake than you do because you just learned this, and I make mistakes all the time, and that's okay. So, did that help anyone? Okay.
I will do it right now.
Okay.
You don't get homework till y'all do this.
I want you guys to be comfortable saying, I got it wrong. How many of you then, so I'm going to move it to this, if you got it wrong, you don't know what happened? Okay, yes ma'am. What happened, or what did you get that was different?
So I put my line going down.
Down.
But how do you know if it's going up?
That's a good question. And let me erase this. So this is what you had, right? So what's the slope, Eva?
1.
So it's this number right here. Is that positive or negative?
Positive.
So so it has to go up. So you can look at that and say, for sure, it must go up. Thank you very much. Your homework. 2 through 28 even.